Hello everybody, it is Mike Levin on Wednesday, November 24th, 2021. I'm a little distracted right now because I'm waiting to make a write on red, one of the great cultural attributes of Pennsylvania, that write on red is legal. However, you do have to sometimes wait a good while until it's safe. Yeah, I have memories of driving to New York with my mom. She was driving and she makes a write on red in New York City, in Manhattan, I do believe. And the cops pulled her over, gave her a ticket, and boy, was she triggered. Angry, you could tell, for almost the rest of the day, with that kind of how dare they attitude. And I just never realized, I never put those signs together, that kind of not being able to get over it was signs of things to come. Hey, they could be signs of things to come in me too, and I'm trying to get over it. A lot to get over in life. You can't live in the past. There's a lot of variations on this expression, but my favorite is, you cannot sacrifice the present on the altar of the past, nor on the promise of the future. So you really want to optimize your now moment fairly well, at least according to the 80-20 rule. You want to get 80% of the reward, of the benefit, of the payback, of the joy of being alive out of this very moment you're in, because there's no other moment you're in. You're only ever in the moment you're in. So it's always a good time to take inventory and to take stock quickly, because you don't want to waste time on taking inventory, and say, hey, how can I most be, well, whatever your thing is. I was going to say most be enjoying life, but aesthetics and such, non-materialism people, it's not about material accomplishments all the time. Very few people, on their deathbed are going, I wish I had more, just more to leave behind, so chances are you're going somewhere else. I am no longer the atheist I once was. I think that we are a lot like antennae, tuning rods for vibrations that seep into the material world. A vibe, you talk about being on the same wavelength with people, harmonious vibrations and all that, crystal and tree hugging stuff. Yeah, I believe in a certain amount of it, because we are in fact standing waveforms of energy, of light. Depends on how you look at it, but because stuff clumps together, a la Richard Feynman, you should really listen to Richard Feynman ramble on about the fundamentals, the first principles of existence, of physics. Not much spirituality in it. It doesn't often lead down that path with him and particle physicists like him, but stuff tends to clump together and orbit and goes around each other. Things exist in relation to each other, and there's fields and there's counterbalanced fields. What keeps every electron probability cloud around an atom around a nucleus of the atom from just collapsing in on itself? There are these counterbalances, and a lot of this points to those fundamentals, constants, the constants of the universe, the constants of existence. And you hear different ones referred to, like the speed of light is the classic one, pi, the ratio of pi, and so these are concepts that probably spontaneously reoccur in other ways at different times in people's lives, and you can understand things at a more almost fundamental and physical level than with a spoken word. Oftentimes the spoken word is a big obstacle to true experiencing of an experience. So even now, putting the language down for YouTube here is kind of throwing me off because I'm getting my thoughts together. I'm clarifying my mind. I'm cleansing the palate by kind of a little opening story that goes kind of nowhere. So anyhow, what is on my mind right now is next steps professionally. I am very happy where I am. I am very happy with the kind of work I'm doing and the people I'm working with. All top notch across the board. I couldn't hope for better. Kind of an ideal situation for a, well, ... and that's what I am deciding right now. So I have gone from, career-wise, in actuality, a print production manager. I just helped get stuff physically produced for a software company, Scala, one of the multimedia, like almost the web before the web, companies, starting out on the Amiga computer, moving over to PCs, but there were a lot of precursors to the web, and I used a lot of them. I used things like Can-Do, an alternative to Scala, kind of, sort of. Scala was oriented towards being a video titler, which later grew into digital signage, but basically taking the place of some very expensive equipment known as Chiron generators. That word is as familiar in a generation of video people's minds as like the Amiga computer is in my mind. It, characterized the state-of-the-art tech that everyone loved to use of the day. So Chiron generators. And so I don't even know where I was going with that. So I learned a lot of programming language. There was Amiga Vision that had Amiga Script behind it. So I learned Amiga Script because I worked for Commodore, so I drank the Kool-Aid. There was also, let's see, there's a few interesting different things. Can-Do was one of my favorites. That would compile, and you could make, self-contained. You didn't need Can-Do to run it. You just double-clicked it and it ran, and people would make these little soundboards, and you'd click the button and it played a sound. It was, how the fart apps are so popular on phones, ever since the iPhone came out. Well, people were doing that with little soundboards they were making on the Amiga and other platforms with these drag and drop user interfaces, WYSIWYG designed user interfaces, usually WYSIWYG, not always, but usually. And you would design the way the user would interact with it, and because the platform, especially the Amiga computer, was so darn predictable, the lowest common denominator was a pretty awesome piece of, graphics capable equipment. So there were a lot of cool demos on the Amiga, and they were distributed on floppy disks. Forget megabytes. These things were 800K. I believe they even started out 400K. The Amiga started out with a single-sided, non-high density floppy disk. So I think it was, after formatting, you could get almost 400K, which is, there's a 1,000K to a megabyte, I believe. Once you get up to 1,000K, it's a meg. Do I have that right? Anyway, a lot of capability was packed into an incredibly small, efficient amount of space. And so I'm having these surreal experiences at work where I'm taking over a Node.js, Vue, and React application, one of each, let's say. And so I'm starting to understand more about the Node.js and NVM stack, which prior to this project, I really only knew Node as what controlled the browser when I used the Puppeteer library. Puppeteer code is JavaScript code that ran on Node.js, and Node.js is capable of speaking the browser protocol. And no one wants to really speak the browser protocol with all these low-level operating system-like commands. You want to talk a level above that, so enter client libraries like Puppeteer. Now, I am definitely taking my next step forward professionally by putting Selenium aside, never fully taking Selenium up, but these are the older methods of browser automation. And it's got a well-developed API, well-known, broadly used in the industry, but mostly based on Firefox and a few other components it can automate. And when it comes to Chrome, it uses a Chrome driver.exe that was never really quite Chrome, and it had to be created for it, and it would get out of sync with regular real Chrome's capabilities. And since it was not Chrome, you couldn't watch it as if it were a running browser, which you could if you used Firefox. So there was really a advantage for the Mozilla browser in the automation world for many years because of Selenium. However, Selenium requires a whole lot of technology that you're slapped with just by using Selenium. So, okay, this brings me where I really want to talk in this video, which is choosing that initial toolbox set of tools that you have at your disposal. When I say have at your disposal, I'm talking about you put 10 years or 10,000 hours into each of these things such that it all comes almost like the spoken, your language, your spoken language, like English for me. As you can see, it doesn't come that smoothly. Anyway, so right now I have reached that level with a text editor called Vim. And another part of the headiness, the weird headspace I'm in right now, is that all roads lead to VS Code. All roads lead to VS Code. I mean, even you PyCharm people, I'm sorry, you're going to be using VS Code. You're going to be giving up PyCharm for all but the most Pythonic things in favor of VS Code because you're going to want to interact with the rest of the world. You're occasionally going to have to use other languages or other environments. And so Microsoft is going to get you. Microsoft is going to get you by even just making their native JavaScript support or native Python support as slick as it is in PyCharm. So with the amount of resources they're throwing at it, you can mark my words on it. And if they don't get you on the slickness of the user interface, they will get you on the must-have plugins and extensions that you can use with VS Code. So it's, quote, free and open source software. So I talked about this in prior videos. I really don't have to, harp on it too much. However, it's not really free and open source software. VS Code is proprietary Microsoft software. Nobody could compile their own version and put it out the same way that Microsoft did Chrome when they put out Edge browser. So I don't see that two-way flow going. I see, Microsoft putting out maybe something that is the fully free and open source version that for some reason nobody knows where to find or how to use or how to compile. And then the heavily promoted proprietary one, which if you can only do things through, you are part of the Microsoft, using generation, the new Microsoft using generation. So back in my day, it was the clone drones of Windows 3.1. There were so many better systems out at the time. It was even a good time to make the sidestepping onto Unix, the Unix platform, because there were some, ways to do it at the time that were pretty cool. The version of BSD, before it was too legally encumbered, I believe, was out there at the time. You could do a classic System 5 Release 4, which was just starting to be able to run on, I think it was a 386 hardware at the time. So there were a lot of contenders. However, through marketing and, sufficiently good product, Microsoft dominated. They almost killed Apple in those days because Apple was being run not by Steve Jobs through those years, but by this guy Scully, CEO from PepsiCo. And so Apple was stumbling. Michael Dell famously said Apple should do a favor and, sell sell out and pay back the stakeholders or something. And, boy, is he eating his words today. But, who can really predict these things? The, compound, unlikely miracles that Steve Jobs pulled off through good advice from friends like Stephen Wolfram of Wolfram Alpha search engine and, API services and such, machine learning stuff, really, I guess. But Steve Jobs was well advised, in addition to having a good intuition for these things, he was well advised by his friends who said, base this stuff on Unix. It's a much better platform to be on than any of this proprietary stuff out at the time. So there was a lot of weird proprietary stuff, but Windows 3.1 won. And it sort of grew into Windows 95, and then Windows NT was out as a parallel code base, and now today everything is on the new Windows NT, which I guess sort of culminated at Server 2000. Windows Server 2000, I think, was that version that was like this apex epitome of them perfecting everything that that they could do on the NT line. And now everything since has kind of been cosmetics, up through, Vista, and I think the Windows 95 code base died out around then, maybe on Windows Millennia. But then the last of the Windows 95, the stuff without permissions and the stuff that was really old school, kind of died on a line there. XP, I think, was the last of that line. XP was the last of the Windows 95 consumer-esque operating system. And then the consumers started getting much more server-based stuff that came out of that NT Windows 2000 lineage, and which really leads us to where we are today, because they're just brilliant cosmetic overhauls. I think even now with the move to Windows 11, what's really happening is a loosening of all the proprietary, the grip that all the proprietary bits have on the product. You don't want proprietary, no one will ever know the bugs until they're exploited, and then you have to disclose, and then how many things do you need to patch, when you could all just be based on the, collective human asset of humanity called Linux, free and open source. Linus Torvalds does lots of favors to the world by A, creating it in the first place, B, letting it be an organic ecosystem-like thing, a lot of, survival of the fittest, Darwinism type stuff going on. Apple even calls their spin on it Darwin, but it's not even the Linux spin. I think theirs is Unix. But however, among the things he did is not embracing the GNU Public License 3, which allows you to make money on the, on the back of free and open source software developers without being obliged to give back. I think that was the TiVo exception. The TiVo exception to GPL2 is called GPL3. So Linus Torvalds never allowed the Linux kernel code base to be under GPL3. He holds firm at GPL2. This is an example of the type of thing he does to make sure that a giving back altruistic sort of spirit infects the thing, which was the complete opposite of Unix in the early days, in addition to sort of an ivory tower, university academic sysadmin. You want, the worst from hell Venn diagram. Make someone both academic in nature and the, God-privileged sysadmin on a school network, a university network. Boy, were those some dark days of Unix. But Unix was winning. Unix won out over some kooky alternatives at the time that were from different lineages, different code bases, the Lisp people. So the Lisp people from MIT and the Media Lab, with such tools as Emacs, the operating system that also works as a nice text editor, that was one of the technological lineages that was not C and was not Unix/Linux at the time, and it could have won. It was these kooky alternative, potential histories of computing that were snuffed out by the overwhelming success of the Intel x86 line and, things that copied it. And so we were stuck with that for a while. And for a brief time, there was some interesting drag and drop build an app technology under VB6, Visual Basic 6. And you hear a lot on podcasts of people hearkening back to those days where you could just code something together, drag and drop. And that, I think, created a large part of the IT consultancy world that did custom applications for business and such. They'll code something together that used SQL Server in the back end, connected to a Visual Basic front end, and bada boom, bada bing, there you have a, custom whatever management system, manage your business on it. And nothing has ever really replaced that. There was stuff like it. There were so many bizarro alternatives of that in computing. Apple's HyperCard was a very early version of that, kind of like the web before the web. But, things have their time coming. The time for things come. And boy, have I been waiting. Boy, have I been waiting for the time for this thing to come. And I have, for example, avoided web front-end development work like the plague for a long time because things were in such fluctuation. The code I'm taking over at work, it's part of the, the edge of that JavaScript wave of versions. I mean, Node.js, I installed the latest of Node.js today on my Windows machine. Actually, I think it was yesterday, but what does it matter? And it broke stuff. So I uninstalled it, a la Windows settings program, and I reinstalled the old version 16. However, the point stands, they're up to version 17, and this is still big API breaking stuff. Every time there's one of these big version number changes, expect stuff to break. They're changing the reality. However, you're like, well, what's the alternative? Node.js is being advanced as a technology. It's this great tool. The language is changing. The scope of what the Node program itself is able to do is expanding. And all this wonderful, cornucopia of prizes is there to be taken for those who master Node. One problem is people like me really hate Node. I mean, it's not that we hate Node, it's that we love Python. And you look at a thing like Node and you're like, yeah, okay, a tool, external tools can be nice. Python wraps everything, right? When you give us another technology, we'll wrap it. However, there's this close relationship between JavaScript and the document object model of the browser, a tight coupling, which when you add to it the way you would operate, the way you manipulate the DOM, these React libraries, these Vue libraries, you've got a very, the words escape me, It's objectionable. I got to tell you that. It's very objectionable. I don't like doing it, but you got to do it. You got to take up APIs that you know are going to be obsolete in a month, 6 months tops. So you're not really investing in your career with this long-term muscle memory, getting faster and better over time, the way I picture like hackers in movies. Their hands are a blur, things are changing on the screen, they're in almost telepathic union with their, equipment. They're in the flow zone state. And I propose to you that this is very, very possible. I propose to you that a large number of people in the world today work this way with programming code. They think in a programming language. You can tell I want to say they think in Python, because the programming language they mostly think in when in this Zen state is Python. Why is it? Because, oh my goodness, what a misnomer Python is for what it is. So, to put it in a nutshell, it was once an interpreted language. And this interpreter is an opinionated little thing saying, when code comes in, here's how you handle it. First you do this, then you do that, and then you do that. And it goes through this very sequential, process, and with a lot of switches, a lot of checks on things. And yes, it's been optimized a lot today, but this concept of the interpreter is still there. Now, this interpreter is like a little servant, little butler, little genie. And it has a pretty good idea of what it is you want beforehand, and has organized its offerings so that it's easy to ask for those things. That's called like the Python core API and standard library. The core API are things that are in memory when you run a Jupyter notebook before any imports occur. So I'm glad I can start putting these things in Jupyter notebook terms, so expecting people will know what the heck I'm talking about. So it used to be there was only this one context for running, interpreted code. That is, you fed the, file name.extension to the interpreter. The interpreter loaded that file and looked at it and followed its instructions. And it was like pulling a trigger on a gun. Now I'm running the program. Thanks to a project called IPython and many other projects like it, over the years. It's not a new thing in Python. It's just a very well implemented thing in Python, as these things are. An interactive console called IPython was made, and then bringing that to a web browser so that you didn't have to interact with terminal so much. That was Jupyter. The Jupyter project sat on top of IPython. And now the Jupyter project, which runs very competently inside a web browser, can be broken out of the web browser in this Electron version that has recently been distributed. So my favorite tool, which is standard Python running in a web browser in a REPL environment. So this is the kind of thing, it'll just be rising in popularity over the years based on how important this is to technology education. Right, okay, so in the olden days, when you had to pull the trigger and run your code, it was either a compiled environment or an interpreted environment. And all that meant is how long you had to wait when, and what it looked like when mistakes happened, and what the process was like to fix your mistake and try again. Compiles pushed a lot of time at this process at the beginning. Every change you made had to be recompiled before you ran it, and then it ran very, very quickly because all the decisions have been already made. It's a lot of predeterminism, and hence the desire for static typing of your variables. You want it to be of a particular declared type and size. So you say of what type your variable is going to be, and what size values can be put into it. And you might even have other validation criteria at that point, saying only numbers between certain ranges or whatever, decimal precision in a float. There's all kinds of meta stuff that can be stuck in, but the heck was I talking about? Yeah, Python, of course. Python is what's known as a dynamic language. Now, because of the processes that these things are optimized with, virtual machine and pseudocode, P code, bytecode, virtual machine code, there's all kinds of terms for it. But basically, it's made for an imaginary machine that is not your real hardware, or at least your real hardware's most primary virtualization level, abstraction level, because it's virtual machines all the way down. Let me assure you, very little knows about your precise hardware in your software that's running. There's these layered up drivers that increasingly abstract things away, making the most advantageous compromises between simplification and performance, until such time as you have an expressive enough language you can use that can pretty much guarantee, top speed performance out of your hardware. Because anything that doesn't has some sort of busy loop or wrong implementation, which can strategically be replaced, like especially under Python with compiled C bits. So yeah, Python is like a Borg language where you can start out with what can be thought of as an interpreted language, running slower than something that's compiled in C. But if you find a part that's particularly slow under Python, you could actually rewrite it in C, compile that C portion, and have that as a component or a part of your package that the Python API, the C API, communicates with to pass information back and forth. That's how the now I guess famous NumPy library works, or package works. That is what's underneath Pandas, which is another very popular package. Okay, so where am I going with all this? Where I'm going with all this is that it's taken a long time, a very, very long time, since anything has been as appealing to me as Electron now is today, because VS Code did the trick very competently. The Atom, ATOM, text editor, did the trick competently. Not the best breakneck performance, but it's getting optimized. Chromium plus Node is a little bit of a hog, but what you've got is the modern day I/O engine. It's the PostScript printer of the modern day. If you want to build a user interface, it's going to be for some web-like API that can be talked to through Node, which is so well suited for it because everything has JavaScript embedded into it, and all web developers now know JavaScript, I think is how it goes. So, one language to rule them all, rah, 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 you can't get away from it. But just like you can't get away from printing PostScript to a PostScript printer back in the day, you can't get around speaking regex to a regex engine. You can't get around speaking JavaScript to a web browser, and those things that, I want to say, controller are controlled by web browsers. But too liberal of a definition would include all web servers, and I plan on back-ending me some Node stuff with Python. Python back-ending of Node whatever. Node automation of Puppeteer. Now maybe Microsoft Playwright. So I'll be switching to Microsoft Playwright for Chrome, Edge, Firefox, Opera, Safari automation because I can. Because Microsoft, just like they forked Chrome and made Edge, forked Puppeteer and made Playwright. Playwright comes with its Python client library. You don't have to pip install Puppeteer, one of the two versions that are out there. You don't have to decide which one to git clone, the original or the person who took it over and tried to make it look more official by making the GitHub repo Puppeteer/Puppeteer. Oh, that must be the official one. So all the lead developers on Puppeteer, the JavaScript official client library for Chrome automation, have now gone to work on Playwright. The two lead developers, maybe not everybody, but development has sure stalled out over at Puppeteer, and things are pretty active over at Playwright. So a major part of what I'm doing is switching my browser automation over to Playwright, and probably using non-concurrent syntax until I really need to. You really don't need concurrent syntax when you're automating a browser. I very much resented it under Puppeteer. I did not like having to use async await, especially before Jupyter was supporting it properly. They have subsequently fixed it. By the way, beautiful job on you people who figured out the event loop in a Jupyter notebook so that async and await work as expected, whether stuff is wrapped in, async functions or not. Wow, nice work. Jupyter continues to be a first-class tool for development work and ad hoc work. Okay, so here's where I'm going. Jupyter notebooks are more than a tool for ad hoc and exploratory work. They are a tool which can help you create your ready for production packages, pip installable packages, or sometimes just your .py file that you'll never put into a PyPy repo. So Jupyter Notebook can, thanks to NBDev, export .py files. Okay, it does it in an elegant fashion, and it does it in a way where, with a little bit of diligence, you can keep your Git repos and your GitHub repos from being polluted with all that .ipynb JSON metadata. So everything file storage-wise for Jupyter Notebooks and Labs is put into a .ipynb file, a carryover from the IPython notebook days. It's good. It shows you the lineage. When you're using Jupyter, you're really using IPython. Brought to your web browser by ZeroMQ, which I'll probably talk about a little more about later because it does come into the picture. Maybe this is where I glue it all together. Now that I'm talking about a glue language, an inter-process communication language, ZeroMQ for Zero Message Queue, and a related package that uses ZeroMQ as a dependency, ZeroRPC, Remote Procedure Call. Okay? So there are two worlds. There's the world of Python, and there's the world of Node.js. These are different worlds, for better or for worse. It's a question of fundamentally different things live together, play together well, and can you build things out of it that are love-worthy, that have both things in it, and you can feel good about the overall endeavor because each part is doing what it is good at, what it's designed to do well. These are, top-notch tools. Node.js isn't going away no matter how much you might hate JavaScript. Okay, so I kind of, tease the YouTube audience, staying on the fence here personally. I mean, I do hate JavaScript, but I am always ready to take it up again and to strive to find the love-worthy bits. Now, I'm usually repulsed by the time I, put together an anonymous arrow function. That's about how long it takes me to go, oh God, really? And then I look at Python and I go, Lambda is not much better. So no one is sin-free in the compromised beauty of the expressive creation language. All tools are flawed. They just push around the flaws, just the way complexity is pushed around. And whether you really love a tool, or you really hate it, or you don't care, or you're the kind of person who just doesn't care about your tools that much, they're out there too. I meet those people sometimes. I'm kind of baffled, but I really realize that you look at archetypes in storytelling, the different types of people there are, the traveler, the journeyman. There's different personality types because different things make people tick. People feed their soul in different ways, different things, different activities, different states of being and ways of being here on this material world. Satisfy, feed the soul, make you have a warm glow in a whole variety of different ways. And now, few things are as tied to it though as tools and language, right? So whether something is love-worthy or reprehensible is often a function of how well that language is constructed for the subject matter. Math. How many people, have like an anxiety reaction just to the word math because it stands for mathematics, and then there's all these numbers, and then there's all these rules, and there's this rote memorization, and then there's these abstract concepts, and there's these letters filled in for numbers, and it's very intimidating to a lot of people, dare I say most people. To most people, math is a intimidating subject. Now, you might say, well, what about art to those same people? And they'll be, oh yeah, I love art. Art I get, some art I get, some art I don't get. But, people find it easier to connect with art than they do math in their minds because of labels, because of conditioning, because of the details of the language of math. So some people really hate Richard Feynman's Feynman diagrams on how particles, join other particles, and energy levels are raised and lowered, and things are emitted. And so Feynman diagrams look a lot like these actual exchanges of energy. They're very vibrant, they're very dynamic, almost hieroglyphic in nature. And then, there's a lot of people who are like, this is ridiculous. It's unlike anything else in math. It's like, ununifiable parts, symbol systems and rules that don't fit together. So you find a lot of hate surrounding that stuff. You find a lot of hate around original thinkers who rework or invent new languages to solve problems in certain new problem domains or old problem domains that need to be solved better. This is a favorite pastime in the Lisp lineage of languages. The Lisp people, and do yourself a favor, read a lot of Paul Graham's essays. He might come across a little bit dated now, a little bit old school, but he, was the original creator of Yahoo Stores. And it was originally created with some dialect of Lisp. It was probably Scheme. And there were certain features of the web stores that even after they ported it to the best thing that people actually wanted to use and could collaborate on, that they could just never get back. Certain features that were beloved features that they just had to say goodbye to. because certain things could just be achieved in this way you do stuff, layering up, nested languages in Lisp. And in a lot of ways, the very popular web design of CSS and a document object model and JavaScript is very Lisp-like in nature, because you've got at least 3 sub-languages there. The JavaScript, CSS, cascading style sheets, and in its own way, the object model of the DOM. It's, a thing apart from CSS. You can style things with it. There are things that are well suited to work together because addressing systems, attaching to nodes and all that. However, it's 3 separate things. And that, while they were not actually created in Lisp, Lisp people look at the web, the way the web works, and go, oh yeah, that's the kind of thing that, we were doing back in the 70s. And so there's always alternative technologies and approaches and ways of doing things. But if they don't catch on and they're not in the mainstream, then you're left out in the cold. Technology is always going to let you down unless it's being carried on the crest of either the mainstream or barely fringe, only fringe enough so that, the momentum of GitHub and everything carry you along. You're carried along with a wave. But you need to have some really, really good differentiation to be worth taking up and to be worth investing the headspace into it. So Rust is definitely doing that. It's yet another C, looking language. They all come from something, I think, Algol, A-L-G-O-L, and I think a particular version 6, Algol 6. So it was the, precursor to, I guess, BCPL, which was the precursor to C, which is the precursor to C++, which is what so much of today's operating systems and highly optimized software is written in, because you do want the performance of C, but you want to be able to use object-oriented. So it's not like a pure, clean object-oriented. For that, there were languages like Smalltalk that were designed with object-oriented, patterns in mind, passing messages between things, which is why Apple was not satisfied with the same C++ everyone else was using. No, they had to make Objective-C so that a lot of the beautiful stuff that Steve Jobs liked from a design standpoint, sending messages around, also applied to the C world. So that's why it's Objective-C in the Apple world instead of C++ like everywhere else. There's also Delphi. There's a variety of alternative technologies in those days that are flavors of C. And they were also popular that they're the standard against which so many modern things are held to. And so many of the conventions of those C languages is just lifted up and automatically used as an assumption in any new language. Rust is a victim of that. Google's Go language is a victim of that. Although the rules are a little different for defendable reasons in Go language. They almost get out of jail free on the curly braces, but we'll get back to that later, maybe. But I'm mostly talking about the curly braces to delineate code blocks and the semicolons to state that a line or a command has reached its end. And even JavaScript is trying to strip these out for a lot of use cases, but now there's places where you can strip them out, places where you can't. And it's just all the more overhead to keep it in your mind. And so sometimes there's a chance to just rethink things, to think things through, how things should be, how you should interpret code. And that brings me back, if I ever lost my train, this recorrects it there. The vibe of the interpreter has a vibe. The vibe of the interpreter can be harmonious with your vibration, you can immediately like all the decisions it tends to make, that all its default behaviors are the same choices you would make, and you find yourself being more spontaneously expert, more spontaneously expressive, and a lot more of the hard work of coding just fades into the background. It becomes a part of your muscle memory. This happens with Python. It absolutely does. It happens with other languages, with other people, I have to believe, just not with me. Well, it did with VBScript, Visual Basic Scripting Edition. Some people long back to those drag and drop Visual Basic 6, days. No, not me. I long back to the active server page, VBScript, active data object, Windows script host. I even like that. Wish. There was something called Wish. Any .asp code you made with just a little bit of reworking to get rid of templating code could be turned into a WSH file and could be scheduled in the Microsoft Scheduler. So this is where I started to fall in love with the more, being free of the web browser way of coding. And so I was very predisposed to scripting languages. When I started understanding the decisions Guido van Rossum was making regarding the Python interpreter, how .py files run, I'm like, wow, I really like that. That is, very much suited to my liking. And as an interpreted language, it's generally slower than these compiled C languages. And compiled C languages, the practice of optimization, the rigid discipline of declaring, typing, and sizing your variables, and maybe even, validating the data that can go into it, is so closely held, such a almost religious dogma thing among a certain, portion of computer science people who went to college for computer science, that there's sometimes a hatred for the more dynamic languages like Python. So along comes JavaScript to take over the world. And now, how in the world could, Python hating Java people or C people ever be okay with JavaScript? It seems like it's the worst of all possible interpreted worlds. The worst interpretation of all interpreted worlds. Well, no, not so. Because there's a build procedure now apparently in JavaScript that makes not pseudocode, not P code or byte code, but actual executable code for your hardware at that lowest abstraction level. Not lowest, but let's call it near lowest abstraction level, that squeezes great performance out of your hardware. So that's why the node modules directory, that's why the build step, I'm getting used to it, npm build, npm run build, something, I don't know. But I'm getting used to the fact that there's a build step in deploying node apps that's it seems, correct me if I'm wrong, but it's compiling JavaScript to executable code like .exe type stuff. And you get really blazingly fast performance out of Node.js, faster than you do out of the equivalent in Python most often. So if speed is your thing, the speed of the running app, now it's not in the development cycle, because I'll tell you, the time you lose as a developer waiting for these builds for every little change, it is enormous, it is huge. It was the same thing that put the onus on Google to create the Go language to replace C for their systems development work, because the compile was just too long. The the money lost waiting for developers all around the organization, thousands of developers waiting a half hour each time for C to compile to test their changes, was unacceptable. So they created the Go language. It works a lot like C in many ways. It has greater awareness of concurrency. It creates really highly distributable packages, fast-running, highly optimized distributable packages. But it's another C syntax, as most of these languages are, and very little, in my opinion, love-worthy about it. I don't look forward to speaking JavaScript for Node. So what am I going to do? How did things really change? I'm almost an hour into the video here, getting to the point. Well, Electron looks like a game changer. Electron is not perfect. It has some, it's encumbered by not entirely free and open source software, the same way VS Code is. So if I'm knocking VS Code for proprietary bits and blobs, I guess I have to do the same thing with Electron. But Electron is in the critical path of having those proprietary bits and blobs stripped out. Maybe everything but Widevine. Ugh. So digital rights management is hardwired in, things that check against databases that need to be updated, and therefore call back to mama, therefore security, private, all kinds of ramifications. So the Electron platform is being made to play nice in the digital media world, so that things created on it, video players, which you very easily would abide by digital rights management rules set by the publishers, the owners of the content. Oh, okay. So, small price to pay for Electron. There's Neutralino.js, and I think Taurino. So, the naming system is all these particle things. But it is important to note that an enormous amount of pressure is being put on Electron for stuff made with it to be distributable within the app stores and ecosystems. The software is sufficiently polished that you can sell it. So, the economic incentive, the push, the promise, the dangling carrot for web developers to be able to create standalone programs that can be sold through web stores, therefore to be able to monetize their work in other ways than being a full stack developer for the man or whatever, is so enormous, it's going to happen. It's just inevitably going to happen. If it's not Electron, it's going to be a fork of Electron. The writing's on the wall, ladies and gentlemen. The world has a new primary user interface, and that is the Electron package, ElectronJS package, with Node in there, because it's just a display engine. It's just the way regex was embedded into Perl. The Perl programming language chose a regular expression engine, compiled it into Perl, and the world has never been the same. Regular expressions are P in the pool of tech. It's pattern matching. For 9 out of 10 times, you need pattern matching. It's the main go-to tool, like it or not. Display PostScript almost became that. There was a big push for that. That was, I think, one of the big differences between the computer that Steve Jobs made for Next Step, Next OS, Next Computer. In the time he was kicked out of Apple, he tried to do it even better for himself. And much of that became what was reacquired by Apple later when Steve Jobs rejoined Apple and bought Next Step, Next OS, whatever. They bought enough of Next that OS X could inherit a lot from it, except I don't think display PostScript. That did not make it. So there was PostScript in printers for black and white and later color, very sharp, high resolution printouts on paper. And then There was a display equivalent of that had some very neat capabilities. But it didn't catch on. It never caught on. It never became the big thing. But if it did, everyone would have been paying royalties probably to Adobe because PostScript. Let's be glad we're not paying royalties for the use of JavaScript and Node.js. Let's be glad that all this stuff is in the free and open source world. Sufficiently glad that we can put any silly nonsense regarding religious dogma of technology aside. All I want to do is not have to write in JavaScript. That's all. I just don't want to write in JavaScript. I'll understand it when I look at it. I'll be able to go, oh, okay, I understand that. But the piece of your soul that you have to spend to have the spontaneous mastery and expertise. You know, I saw a YouTube video. Okay, two things I saw. Quick sub-referencing. One of them is, if you're learning to code, you probably have some billion-dollar idea in mind. False! You're learning to code. You might just want to be literate in the modern world. You might not want to be illiterate in the modern world. Learn to code so you can express yourself in ways that machines can understand, that you can automate, that you can bend material and matter to your will. Learn to code the same way you would learn to, you know, speak, right? Do it for yourself. Do it for your soul. Do it for, you know, always being relevant or whatever. I don't know. So the other thing I heard is that the main thing about computer scientists is just to be able to Google things. A modern data science or computer scientist or whatever is just someone who can look things up, and then the implication is you copy and paste off of Stack Overflow. No. Your real expertise is, you know, to what extent you can pick apart and be a critic of content you see on Stack Overflow based on your even deeper understanding of the tools in question. Now, next comes the things you can't really be a master of at that level of that many tools. You have to pick a smaller number of tools and master them to the nth degree and being your life. You know, you're talking minimum 10-year runs. If the technology you're using doesn't have more than a 10-year run, then by the time you have achieved total mastery of it, it's obsolete. What do? You take up things like Python, whose APIs don't change that often. That's why the numbering system is only up to 3.10 after 30 years. 30 years, version 3.10. That implies a certain non-volatility in the APIs. And, you know, there was a lot of pain going from 2 to 3. The stuff they left behind is beloved stuff. So it's hard to go through these API upgrades, changes that way. But Node is doing it like all the time. Node version 17, I tried installing it. Everything broke. Had to roll back to 16. So, you know, JavaScript is a young person's game. If you're going to live it and breathe it, if you're going to live in that volatile edge of constantly changing APIs and constantly having to rework your software, rebase it, or whatever, you know, it's even if it's fixing things, even if it's running scripts that'll do the work for you, you know, Pi 2 to 3 or whatever. There's a lot of that in the Python world. It's fatiguing. Very, very, very fatiguing. And it's the big reset. It's the undo. Any muscle memory you had for the old way is, you have to rework it at very minimum. If the APIs have changed a lot, or if you rely on a tool that has changed, you know, that's it. You know, years of accumulated experience have poofed into the abyss because you learned the macro system of this version of that software from this vendor during that era, and they're now, you know, a 0.1 version beyond, and, you know, your world has been rocked. So what is the solution? So I told you Python for, you know, mostly, you know, less volatile APIs, right? Python adds space, adds things in available space, walrus operators, switches, filter switches, and in things that have not been used for other purposes yet, which would be invalid syntax otherwise. And they do it cautiously and over great periods of time, after a lot of vetting and discussion, PEPs they call them. You can go see what everything that's being proposed right now. So where else? How else? Well, certain things you just can't get away from the volatility. I'm switching to a different package to control my browser automation. There's going to be new stuff I need to learn there. That's fine. I'm getting used to async await, some extensions to the Python API that, very much mimic how JavaScript is doing async await. And, certain places you can't get away from the relearning, or, hope that instead of relearning, it is extensions. It's just things you add on so that all your existing muscle memory still applies exactly. So Linux/Unix, text files in Linux and Unix. It brings you a surprisingly long way. One of the readers, one of the YouTube audience, had asked a question: what do I think about, and he named a few technologies I'm not very familiar with, but upon Googling them, I saw that one of them was Emacs, Emacs as opposed to Vim. I'm a Vim user from the VI lineage of text editors. He was using, maybe not the Emacs exactly, but one of them maybe from that lineage. There's a few of them. And he said plus Guile. And I think he might have mentioned a few other surprise, really old school programming languages thrown in there. But the one that really stuck with me was called Guile, because I didn't know Guile, so I Googled it, and it touts itself as part of the GNU, set of tools. So there's a lot of stuff under GNU, such as Linux itself, and all the commands that are with Linux. But then, prescribed part of most distributions of Linux, things like Screen. You'll find a lot of loyalty towards tmux out there. But for this type of tool, there's one called GNU Screen, and there's a few different things like that. So under that GNU set of tools, one of the languages that's available is called Guile. And it has a lot of guile because it remains language agnostic and allows you to do a lot of the types of things you would be using modern script languages for. It looks like it could be a replacement to batch script. It looks like it could be a modernization of batch script. It's got that feeling to it. So a modernized batch script plus a version of Emacs, yeah, sure, you're going to be able to do a lot of stuff. However, the thing about Python is one of the many the thing about Python is that there are many things about Python. As tempted as you are to pinpoint one thing, like the abundance of packages that you can just pip install, which is where I was going, you have to pull back and go, no, that isn't the thing about Python, because that's kind of relatively new that all stabilized. The Node community had NPM working right from start, and the Ruby community had the GEM system built in right from start, where the repos were like part of the language when it was released. Python had to come around to that, and that was not the most painless process either. The PyPy organization had to, modernize a lot of stuff, and be ready for both the security and scaling implications that came with Python becoming so profoundly popular. So PyPy grew up quick. The whole pip install thing became a lot more formal, a lot more tight engineering-wise, technology-wise, scaling-wise, all kinds of things fell into place with pip install and Python packaging index really late in the game. But you got it, and what it's installing is from a profoundly mature, long-running base of software where you don't have just merely one solution to most problems you'll encounter. No matter the itch you need to scratch, there's probably not only someone who scratched that itch before and has published a community resource, a free and open source community resource for you to just take and use. There's probably 2 or 3 of them that you have to compare their philosophical underpinnings and their principles and their APIs and their performance or whatever other metrics you're going to be comparing. And then if they're not good enough, you can make it yourself, which might be a pleasure because the whole Python packaging system is kind of getting pretty cool to do. And you might want to take what you created and distribute it out without web serving in the picture. I am so fatigued on everything web, including having to have servers in the picture. And I am very much inspired by the standalone version of Jupyter. I mean, I was already pretty impressed by what VS Code did on the Electron platform and a bunch of other stuff like it. I think Slack is on the Electron platform, and I didn't like loading Slack a lot. That lagginess and overhead that people complain about with, Chromium plus Node, having to be there, having to be in memory, being something of a resource hog all the time. Yeah, I see it. I don't leave Slack running. I get it. However, for lack of anything better at this time, and apologies to Neutralino and that other Taurine or whatever. Apologies to the other platforms that are trying to make it happen. But that T1 doesn't run on Python yet, so I can't use it. And Neutralino, maybe, I don't think Neutralino runs on Python either. It's neutralino.js. But what you can do is step in there with Node modules and communicate with any Node module with Python. Yes, ladies and gentlemen, there is a formal API bridge called Python-script. I think it's called Python script or Python scripts, but it's NPM just like anything else. So it's NPM install Python scripts. And now you've got a way that you can have Python talk to Node. Now, it doesn't solve the whole problem, I believe. I believe there's one thing left that has to provide a channel of communication between the two. And I believe when you actually craft a solution around this, you do need 0MQ in the picture or something like it, perhaps a web server. Web servers could serve the same purpose of passing information between systems, but I'm infatuated by a incredibly low latency, high performance, running local with no mishmash of servers, message queue system. 0MQ is really cool technology. So 0MQ plus Python script running a Node module, running on Node, so Node running Python script, running your Python scripts, some part of it communicating through 0MQ in ways that I still need to understand, because inter-process communication is actually required here for at least one step. I don't know if it's a bi-directional thing. See, I don't think so. I think that when you look at the parts, what you're going to find is that there's something like, a lot like web server capabilities that are trying to spring into existence by having a Node JavaScript main main.js, perhaps index.js, that node starts running. So it's like node space index.js, kind of like an entry point thing. And when you have that, you now have JavaScript running in a very web server-like way. And so there's your API, right? You can build things that talk to Node. No, it's the user who talks to Node. You touch user interface things, you click things, and the Node runs JavaScript. And part of that JavaScript is the Python script node module. Consequently, touching things in a user interface can run Python. Python often backends things, so it can be running separately in some other context, communicating to things in the web browser, or responding to actions in the web browser. So in this case, you touch something in the user interface. JavaScript is run. The JavaScript that's run is telling Python to run. Python runs, populates native Python in-memory objects. That native Python in-memory stuff has to be shuttled back over to the JavaScript Node.js side. That's where your message 0MQ messaging comes in, because it sends something over a messaging channel back to Node. It makes an HTTP-like request. With Node, it doesn't even have to be HTTP. There's other ways to do it, I believe, but I think maybe 0MQ is using HTTP. So, like web page-like requests can be made with objects. Objects either on the GET request carried on the URL, or objects on the POST request sent in metadata invisibly along with the request header stuff. And in this way, you are sending Python stuff to the Node world, where it will get turned into JavaScript, turned into JSON perhaps, I'm not sure, and hit ready-made targets. So this is where, if you are running something in Python that's responding, it's responding back to the caller that was written in JavaScript that made the request in the first place is expecting a response. So Python is sending the response back. So it's just a little request response cycle with a bridge between the JavaScript world, the .js file world, and the .py file world. And the way that the .py stuff, because it's decoupled, there's some questions as to whether the Python engine is instantiated on every request or not. I'd hate to be back in the CGI days. But there's going to be some questions there about the persistence of Python execution environments. Wow. Active server page days all over again. Yeah. Compiled bits with retention. Yeah. New context, new execution context to wrap my head around. But part of that execution context is one of the holy grails, such as it were, of user interface work these days. The days of Can-Do and Amiga Vision and Scala are back upon us. These are Amiga things I used to be able to do, to just cobble together user interfaces, and now it would pretty much run anywhere because every Amiga is the same to a great degree. And now, for the first time, I know there was TK Inter, TCL, TK. I mean, I was a TCL person back in the day, so the thing that Python borrowed its primary widget building user interface from, I knew from back in its first rendition. But I never got excited in any attempts to build user interfaces out of it or any of the things like it. And there's a lot of stuff, there's you can listen to podcasts about, I can't even, it was so undistinguished, I can't even remember the name of it. WXL, there's different layers, there's different rendering engines to webify Python. Exhaustion. And to make different user interface building systems, but there's not one to rule them all until Electron. Electron is becoming the one user interface to rule them all, if it's good enough for these mainstream things that are now becoming really, in the spotlight. I mean, VS Code, the Electron platform has to be rock solid now just because Microsoft is using it for VS Code. You too can build on the nearly free and open source ElectronJS platform and make distributable, compiled, at least bundled, tightly bundled, so all the resources are required, distributable EXEs that will run, I believe. It might take some special prep to hit all three platforms, but you can compile executables for the desktop of Windows, so make Windows apps, Mac, so make Mac apps, and Linux, other Linux desktops, usually GNOME-based Linux, because that pretty much won. If you're on Ubuntu desktop, you're on a GNOME-based Linux. There used to be Ubuntu Unity, an alternative that was being pushed onto a lot of people as part of Michael Shuttleworth's vision, but that was kind of given up in favor of just going with the flow of the free and open source world. Some versions of the Mint, distro became popular because they embraced GNOME where Ubuntu didn't. So Ubuntu paid the price in that, and popularity losing a little bit here and there. There's also the KDE interface, which came from, I think, proprietary in the day, and then was released out. It was alternative. So there's something called Qt that a lot of this stuff is built on. It's an alternative to the Tinker, TCL-TK library. So there's been a few things out there to try and hobble together user interfaces for different platforms. It was bundled tightly enough. It was never mainstream supported enough. It never looked good enough. Everything looked a little bit weird, not like native OS stuff. Certainly there were performance issues, and very little of it ever caught on. This is why there's been so little since the days of VB6, Visual Basic 6, that filled this role in the mainstream world. I guess it was Windows really in those days. Today, it's got to run on multiple platforms. Running just on Windows won't cut it. It's got to be multi-platform, means all three platforms: Windows, Mac, and Linux. There's others, but so Electron is the components of Chrome that have been sort of deconstructed to be reconstructed into a web app with no address bar. That's Electron. It's pretty exciting. It can use all the web technologies you're used to, so I'm very much looking forward to doing things like OAuth authentication in a little box that is not a formal web browser, but is a formal application development platform now. I can make Pipulate standalone, file storage and local database using SQLite. The sky's the limit. It's a lot of things that you would normally need a server in the picture for and develop as a real web app. You can say, it's a web app, but you just don't need a web server. It's all self-contained. So how do people run it? Well, you just download this and you run it. The install, I'm going to have to look at that, bundling things for distribution, and then keeping those versions you have up to date. How much is really going to be pulled off of the web after all, because it's a convenient way to update stuff. So these are questions I'm going to have to answer as I take up ElectronJS, so I can familiarize myself with Node in a love-worthy way. Node talking to Python, continuing to leverage all my Python know-how, quote, on the back end. However, a lot of front-end stuff is going to be handled by Python too. How much has yet to be seen. One of my questions is, okay, it's probably going to be Vue.js on the front end, version 3 of Vue, because I got to modernize myself. It'll help familiarize me with the stuff I need to know at work. I won't be learning a version that's imminently obsolete. Hopefully Vue will have a year out of it. Vue version 3, a year, you think, maybe. But the principles, there should be people striving to be API compatible now, I think, maybe. So my alternative there, if Vue isn't enough or isn't the whole picture, I am pretty pumped on HTMX, which is just a Python way of swapping out rectangular regions of your DOM, basically divs and stuff, with, it's modernized Ajax, strategically replacing elements and contents of elements in the DOM using a convenient addressing language. It's just almost like another addressing language, like CSS selectors, XSL. No, it's XSL. What is it in the web terms? It's XPath in this context. XPath, which is a selector for XML and XSL, which is why I think of it. But these path addressing things, it's like, why go through all the trouble of addressing these paths if you can't also say swap this with that? So both address it and replace it with something that you have just created with the intention of replacing it once you pull up the address. And that's HTTPX. It's a, sensible way of manipulating the DOM, which is not, 100% dependent on JavaScript libraries du jour. There's a lot of pain in tying yourself to something like React. React, there's a lot of tying. Oh my God. I've been doing the browser automation against what I now see to be React-built sites. Oh my God. So classes everywhere, but not an ID to hang your hat on. It just looks unstructured, it's sloppy, from a Vue source standpoint. I was used to sloppy with all Microsoft's attempt to do this. ASP.NET and its Vue state variables. It looks like, as complexity gets pushed around, okay, because that's all these technologies are doing. And, once you push around the complexity, when are processes handled, how is rendering happening, are there opportunities for concurrency, not blocking? All these questions are just, ways in which code gets run, pushing around the details of the answer until you get a scenario, a way of doing it that suits you, that you go, oh, okay, I get it, and I can do this. So, I think there is finally the pushing around of these various complexities to the point where I can live with a local install that uses a lot of the packaging methodologies that the Mac made popular, with apps directories that are posing as apps, really. Folders, directories that are posing as apps. And that way, without a compile step, you can carry around all your dependencies. When you double-click the icon, it runs something in a more of a script file-like way of setting paths, knowing where resources are, loading most of your resources out from local where you are. This is why Node that node folders get so big with Node.js. It really is loading those dependencies in there. But this packaging way of doing stuff really makes it possible to do it for multi-platform. This is what I did with Linux with my QEMU-based version respin of Tiny Core Linux. If you double-click that from a Mac, it's running. If you double-click that from a Linux desktop, it's running. If you double-click it from Windows desktop, it's running. It seems like an impossible miracle, but the world finally seems to be catching up with these methodologies, and it happens to be taking place under Electron. Some more noble attempts are being made than Electron, such as Neutralino.js. But as noble as these attempts are, sometimes you gotta go with a bloated hog because it's mainstream. Because all the support is there. Because the ugly burrs that are still stuck on it that need to be sanded off are going to be sanded off over time. Widevine might be able to be disabled in Electron distros so that things could get into the web stores. Or, or Electron forks will be made that don't include Widevine, free and open source. So the things that do the trick of packaging Chrome as Electron redistributable components has to remain fairly in the free and open source world without it being, locked down this proprietary path so that other forks can be reasonably be made off of it. Alternative ways to do things so that you can always compile your Electron apps using the portions of the Chromium that only the portions you want. That kind of stuff, right? So that's going to happen. It looks like the web as a development platform, is occurring. It didn't happen under Palm WebOS. Didn't happen under a lot of these different competing technologies. I remember back in the day, there were .hma files and .htx files. There was, HTML for applications from Microsoft that raised the, security context, privileged context of code executing in JavaScript, and I guess also VB script, I'm not even sure. But certainly JavaScript and HTML files. I had a friend, Gerard Bucas, who made whole applications that relied on and used this trick. And so it's all just really coming around again. And there is now something worth wrangling for very, desktop-like apps. Oh my God, did I miss? No, there's still one more. Yes. Oh, this last exit always scares me. Finger Lakes. All right. I am going to wrap up real soon now. It's an hour, 33 minutes. This is a good one. I guess this whole thing is like, what's next? So what's next is, a bit of formalization of all the bits of the picture that I put into things. I'm going to be doing formal data pipelining for a computer science, data science oriented workflow. So that probably means Kedro, which I learned about from Talk Python to Me. And I'll be using that with NBDev, something that's not talked about very much on Talk Python to Me. I'll give credit to the other Python podcasts. I can hardly even remember, but .NET, I think it is, podcast.net. Yeah, Jeremy Howard and the NBDev development tool to turn Jupyter notebooks into really powerful, software development tools. And hand in hand with that, I will be using Git. You can't get away from Git. So Git plus NBDev plus Kedro for data pipelines. Jupyter Lab installed as a standalone for an exploratory place for a lot of development. I'll be using Vim. So the Vim and Jupyter Lab combo, I'm really going to be presenting to the world as an alternative to VS Code. If not VS Code, then what? Notebooks as a general practice for exploratory, but then also developing extractable things. Vim, starting your Vim career, your VI, Neo Vim, doesn't matter. Just anything where you can get better at it over time as a function of muscle memory. And yeah, of course, Linux and Python, latest version of Python 3.10, rah, as much as you can get on it. We're stuck a little bit older while we're on Jupyter Lab, but maybe I'll update Jupyter Lab. Maybe I'll get into experimental builds, daily builds, I don't know, but something like that. And then, of course, using the standalone Jupyter Lab as the inspiration, standalone whatever, SEO Kata, Pipulate, stuff using, authentication in that little box there, OAuth screens popping up, you approving it to give things, your level of permission on things that are running in that box, nothing calling back to mamas, that's not the Google Authenticator, for example. And you'll be able to see as part of the free and open source code, and of course, all your data being local and SQLite, so ways to manage that. Rudimentary file system catalog stuff local. That about covers it. That's my next steps. I might throw Rich into that stack because it's hard not to pip install Rich at this point for, when you're a terminal lover, as I am. So I'll probably, format my pandas data frames in terminal. A lot more Figlet, big banner-sized text in the terminal. Now that the line wrap with color codes is addressed by Rich. There's a lot of interesting stuff. The terminal as a viable user interface to the web, as a viable alternative user interface for software than the web. Wow, if Electron can open a terminal inside your web, wrapping within wrapping. So, a lot of this stuff is, interesting to think about because things wrap things, and you can have stuff enter worlds that they're not usually accustomed to. A lot of HTML can get injected into the terminal, and terminal can get injected into HTML. It's very interesting. Gotta spend some time to think what it means beyond just I have can do again. Can do. Can you do that web app? Can do, because it's going to be a desktop app. It's just going to run local. Oh yeah, we can put it on a web server if we want to dedicate that space. Just give it a generic whatever web server. Anything that runs as a desktop app can also run as a web server. The interface will be identical, just coming up through a remote web server. So yeah, a lot of excitement there. Your local dev instance is your app. Yeah, your local dev instance actually is your desktop app. Yeah, I like that a lot. Thanks for joining me. Hope to talk to you again soon, and don't forget to subscribe.